All right, we're back. Yay! All right, hello Elizabeth, Adiba, Didi. Yay, Eric, you're in. Hopefully, both of our microphones are getting sorted out. I don't know why this computer is not working, so we'll do all of this later. So let me go ahead and enable the chat so that you guys can type your questions in there. All right, so your speaker, yeah, all right, we're going to do that later. Yeah, the phone call, we've already called in. So if you're having that issue, enter, yeah, join by phone, okay, yeah. So we're going to go ahead and share this screen and then go back to that. Now I think, let's see, if somebody could reach out, because I know we had a couple other people on there, and just text them the meeting ID for it, that would be awesome. But I'll go ahead and record it as well, so you can share that with them there. And I think Elizabeth, let's see, yeah, we'll check the speaker later. You had asked about this part right here, the product of two positive numbers. You know, what do we have going on here? So when we look at this question, let's see, we're going to go ahead and choose one. Yeah, we're going to go ahead and do that. So when screen, okay, so we're sharing that. All right. So can somebody go ahead and type in the chat window, because I just want to make sure that you guys can see this. Where's the chat? Can you hear me? Yay, okay, cool, thanks, Adi. All right, yes, awesome. All right, so Elizabeth, you were looking for, I think it was you that was asking about this question right here. So let me go back to this guy. Was it here? Yeah. All right. So so this part, yeah, we know. Okay. Continue without meaning audio may not be fully recorded. Hopefully, we'll see. All right. So when you take a look at this guy, we're taking a look at two pieces. One is going to be, they tell us the product of two positive integers is 225 or 1225, Christmas Day. And also the day after my girlfriend's birthday, pretty cool. So they tell us that is one of the product of two things. So we don't know what those two numbers are. I'm just calling them X and Y. Now, you have to solve for one of those, and it doesn't matter which variable you want to solve for, whether it's X or whether it's Y. So you do that, and that's going to give us that equation that's on the left. And actually, let me go ahead and just kind of snip that, and so we can kind of talk about that a little bit more. So when we have that kind of piece with it, we're going to take a look at the product, and they tell us what that product is going to be. So you're like, thank you, I know what the product is. Now, when we do this part over here, you're going to solve that for one of the variables. Now, the sum, so if it's the sum, because we're asked to find the minimum of the sum, so that means this is the equation we're going to want to take the derivative of. Whatever this X and Y is, we're going to add them up and then find its derivative. Now, this piece over here that I've got highlighted in yellow, this value, when we solve that for Y, so that's going to go into our sum equation for Y. That's just going to replace that guy right there. Now, one way to write it is like this, because anytime there's just a constant in the top, I always like to move the variable up into the numerator and just make the exponent negative. So from there, we can just go ahead and take the derivative on that. And the derivative, so just remember your derivative rules, and so I call it S prime right here. So derivative X is 1, and then we have negative 1225X is negative 2. So now here, this is one of the things we want to take a look at. It's kind of cut off, so I'm going to rewrite it. If you have 1 minus, I'm going to write it like this, 1225 over X squared. So what I want to kind of do with that is make sure I get a common denominator. So 1, I'm going to change that to X squared over X squared minus 1225 over X squared. And then that way, I can also pay attention to anything that's in the denominator. So X squared minus 1225 over X squared. So because remember, you're going to have a critical value anywhere the first derivative is 0, so that's the top part, or where the function is undefined, or where the derivative would be undefined, and that's in the denominator. Think of it as a vertical tangent kind of problem. So X squared is 0, if we solve for that, we get x equals 0, and that gets ruled out because the directions, it says find the product of two positive integers. All right, so 0's gone. Now, this x squared minus 225, x squared minus, or 12 to 25, we set that equal to 0. And this is where you have to be really careful, because when you square root that, don't forget to do a plus or minus with it, because these are what are going to be called critical. These are your candidates. So our candidates, when we square root 1225, and I think it was 35 if I remember right. So then you get plus or minus 35. So those two guys right there, so 35 and negative 35, those are my two candidates for a potential answer to this problem. Now, because the problem says it has to be two positive integers, then I'm going to throw out the negative 35. That guy's gone. So if x is one of my values, then I can plug that into the product equation. So I'm going to have 1225 divided by 35, and that's going to give me my value for y. All right, so when we do that, then you end up coming up with the y value being 35. And then the question, this is one of the things I want everybody to get a little bit better about, is answering the question, because it says find the minimum sum. So on some people's quizzes, they would just put a 70 and circle it. That doesn't tell a grader what 70 really represents. So always make sure that you write a sentence that identifies what it is that 70 thing is that you just circled. So like here in this one, you can see minimum sum equals 70. All right. So does that help with that one a little bit? Trying to make sure, and say if you don't show a negative in your work, we get marked down points. Yeah, you will, because that right here, so you can leave that as plus or minus right here, or you can separate them if you want down there, because negative 35 is one of your candidates for that, and that's what the AP, what College Board will kind of refer to that as. Those are potential critical values for this. All right, so does that make sense, Adiva? Are you good with that now? All right, coolio. All right, who else has got something? Oh, Eric, you put a slide in. All right, to the slides we go. All right, let's see what the slide says. So going down here, number 6 on the quest, number 13 on the quest. What do you do to find critical numbers x equals 6 and x equals 2? What format of test question should we do? All right, so let's take a look at the quest part first. So quest, and number 6 and number 13. So is this a quest? All right, so number 6. So Eric, are you talking about number 6 on the on this number 6 right here, right equation of the tangent line of the graph? Yeah, okay, cool. So this one, oh my gosh, this one is so, my goodness. So there's a couple of things going on here. So write an equation for the tangent line. So again, we need two things. We need a point and we need a slope. Now we have to be really careful of is when they talk about this part right here, the origin. So we know at the origin that our x value is, of course, going to be 0. So, oops, let me hide that one again. So when your x value is 0, then we're going to have to find the corresponding y value for that. And the corresponding y value for that is going to be pi over 2, because our cosine at 0. So you think about what which x coordinate on the unit circle has a value of 0, and that would be at pi over 2 and negative pi over 2. The domain restriction for our cosines only uses pi over 2. So there's my point. All right, so that's the very, very first thing, is to come up with a point 0 comma pi over 2. All right, and for a lot of people, that tripped up a lot of people. They would just, because you see this phrase at the origin, you're like, okay, you'd put in 0, 0. And I think we changed this one to say at x equals 0 instead of just at the origin. So at when x is 0, your y value is pi over 2. So that's the first thing that you're going to do on this guy, is come up with our point. All right, so once you get the point, then we can go ahead and work our little derivative magic and come up with the derivative of arc cosine. Now be really, really careful right here, because the angle of arc cosine is x over 2. So that's going to be this 1/2 that you're going to have to make sure that you add in when you do the derivative, and that's your slope. So again, this one's going to be square negative, so that your arc cosine formula for the derivative of arc cosine is going to be negative u over 1 minus u squared square rooted, or negative du. So whatever is this guy right here, this negative 1/2 part, that's going to be the derivative of your angle. So the angle part, that's your u in this case, which is why down in here, you know, we kind of plug in x over 2. So when you square that, just be, you know, a lot of times people want to expand that and everything, and always just keep it simple. Because if you plug in 0 right there, like, you don't have to go really far and expanding, get common denominators. Like, just keep it simple, because that's what's going to make it go quicker. Because if you plug in 0 to this term right here, you're going to end up with 0 no matter what. So 1 minus 0 is just 0, or 1. And then when you square root 1 in the bottom, so let me kind of do this out on the side. So you're going to have negative 1/2 on the top. So I'm going to rewrite that like that. And then the bottom is going to be 1 over the square root of 1. And square root of 1 is just 1. So that's why you just end up with your slope being negative 1/2. Now, once you get that, we've got our point, we've got our slope. Then it's just a matter of plugging everything in to our equation for standard form. So y minus y1 equals m times x minus x1, and then off you go. You can have any of these versions in here, and they would be okay. They would be okay. So does that make sense on that one now, Eric? Are you good with that? Just go ahead and type a yes if you're all set with that one. Yeah. Well, that's why we changed this one. So at the origin, because the original problem said at the origin, and I think it was an arc sine. So when it was arc sine, we just made a typo when we typed that in. So x equals 0. So that tells you that your x coordinate is 0, and then you have to find the y coordinate. If it was at the origin, your x coordinate would be 0, and so would your y coordinate, which of course we know our cosine of 0, that value is not, when the x value is 0, the y value is not 0. So at the origin, your coordinates of course are 0, 0, which is not the case if our arc cosine value that we're evaluating is at 0. So that's why we had to change that, because we had a typo on there. All right, cool. And the other one, I think same test, right, Eric? I think it was number 13. Was that the other one? 19, 11, 12. Oh, 13. Yeah. Was it this one right here, the maximum dimensions one? Yeah. All right, cool. So with this guy, so with this one, when you take a look at that, so you get your volume equation. This is one, it's one of these things where it takes a little while for people to get the hang of, but then once you have it, you're like, okay, cool, I totally got this. So when you, anytime you look at these kind of problems, you're always going to pay attention to the dimensions that they give you. And when they give you these, let's see, oops, no, I don't want you. I want you here. When you look at the dimensions they give you, they tell you, like, all right, we've got a square piece of whatever. So when you have that square piece of whatever it is that you're working with, cardboard, sometimes it's, you know, some other shape or some other type of material, that means every side is going to be the same. So if I think about the original piece, and I know that's not rectangular, so, or that is rectangular, so if you had a square, right, there's about a square. If you cut out this piece right here, every corner, all right, that's what's going to end up being done. Now, I know the whole side is 12, but I just cut out a little piece right here. And each, you know, and there's square pieces that I cut out. So equal squares get cut out. So on the box, when I fold that up, instead of this whole side being 12, because I take out this x and this x, so these pieces get taken out, which means instead of the whole side length being 12, it's going to be 12 minus 2x. And then this part's going to be 12 minus 2x. And the part that we take a look at is from 0 to, and then the height is going to be just x. Now, we get our two, so I see you understand where you're good up to coming up with 6 and 2. Now, one of the things you take a look at, this 12 minus 2x, part, that's got to be greater than 0. So when we take a look and we solve that part for our domain, like our x has to be smaller than 6, because if we put 6 into this part right here, this 12 minus 2x, and 6 was our value, that would just end up being 0, and of course you can't have a side length of 0. So we're not going to test on the other side of 0, because also if you think about that, this part that would be the, I guess the height of our box, we can't have a negative value there, and we can't have a negative height. So we only want positive values for that. Does that make sense on why here we just have a soft bracket right there, and on the end right there? Are you good? Okay, so if you do the second derivative test, all right, so the first derivative, we got that value. Now, if you do the second derivative test, so you're going to have f double prime, or not f, you're going to have v double prime, you would end up with, let's see, 24x minus 96, and v prime of 2. So 2 would be the only value that that we would take a look at, because again, 6, you know, we wouldn't worry about that. So v prime of 2, if you plugged in 2 times 24, so we get negative 48. So that value right there would indicate that that's a max. Okay, which is cool, because that's what we want. Now, if we look over the first derivative test, we also would have gotten a max. So that's the piece. Now, your second derivative test, and this is where it always gets confusing. So if you plug in 2 to the second derivative, you get negative 48, which is less than 0. Now think about what that means. That means you're going to be concave down. So this is concave down like that, or like that. Which one of those is concave down? All right, so this guy is concave up, this guy is concave down. And anytime you're concave down at a particular x value using the second derivative test, that value is going to be a maximum. Right. So at x equals 2, then that's going to be a max, which is what we want. So for our x value, then our dimensions. So we have to plug our dimensions back into our original piece right here. So so x equals 2 is going to be that side, and then 12 minus 2 times 2. So 2 times 2 is 4. That side is 8. So these two sides are both 8 inches. And then the last side is 2 inches. All right. So, and again, this is where, you know, we've got to analyze what the question's asking, because one part of the question says, you know, find the dimensions of the box. Okay, so there's our dimensions. And then the other piece says with maximum value. And then there's our maximum value. All right. And in both of those, make sure that we include the units, because units are important. So that help you with that guy? A little bit, Eric? Yeah, cool. Very cool. Awesome. All right, so who else has got something? DB, got anything else? Elizabeth, yeah, you got anything? Oh, we got a new message. What is it? I do. All right, DD, what do you got? Did you put in a slide? And while you're putting that in the slide, I want to go back and talk a little bit. Let's see, which one was that one? About the other guy that was there before. This guy? Nope. Yeah, I want to talk about this guy, because I feel like I wanted to clear this one up a little bit. Now, when we talked about this one, we're taking a look at this these values right here. And the one part that they tell us, they're like, oh, f of 1 equals negative 2. So they're telling us that particular value. So when I plug 1 in, I get negative 2. Now, the question is, how do I know that if that's negative 2, so if I think about that from this perspective, so here's x value of 1, and here's an x value of 2, and I know that at 1, I get down here to negative 2. So how do I know that when I get to 2, that that's actually going to have a smaller y value? Well, when we take a look at our derivative graph, right here is below the x-axis, which means my slope is negative. So if I'm talking about the original function, that original function has to go down before it turns around and then comes back up. at x equals 2. So that's how I know my y value at 2 is going to be smaller than my y value at 1 when x equals 1 on my original function. So that's why f of 2 is going to be the smallest value on there, because we're continually decreasing, going from +1 to +2 on the original function. So hopefully that clears that one up. All right, so Google Slides. So Eric, you put a couple more in. Can we go over the free response question on the miscellaneous test? Yeah. So miscellaneous test, is that this guy? No, that's not miscellaneous. So miscellaneous. So let's see, miscellaneous. All right, so the free response. Now I know I did a video, I think it was this one. Yeah, this part right here, 205, and I had a typo on here. That should have been 1/3, but when you take a look at this, there's going to be kind of 3 pieces, and this was, I think it was 2005s or 2002s. This was one of those guys. So is this the one that you wanted to take a look at, Aditi? The first one? Or did you want to look at the second one? Because this second one right here, I did a little video for that for you guys. So where is that one? So if you take a look at this important update for Q2 test, there's a video that explains that one for that one short answer. Oh, you saw the video. Okay, cool. So you'll only see the first one. All right, where were we? Go back to here. All right. So for the very first one, we know certain things. Now, one of the pieces that's kind of, it gives you a clue, like you've got volume, and our volume formula has 2 variables. It has an R and an H. One of those is going to have to go. Now, the one that goes, you'll kind of be given a clue about that when you take a look at the information that's provided in the stem of the question. And the question says, if the water in the container is evaporating so that its depth H is changing at a constant rate of -3/10 centimeters per hour. So the depth H, so H is your height. So that means that's the variable that you're going to want to keep, and R is going to be the one that has to go. So from the original the first sentence there, it says container is shaped of right circular cone. Yeah, that's nice. The height is 10. So if the height's 10 and they tell us that the diameter is also 10, then that means the radius is going to be 5. So this in part A, you'll see this ratio of R over H. And I know that the radius is 5 when the height is 10. So I use that ratio to then come up with a substitution for R. So once I get R to be 5/2, I'm going to take that 5/2 and I'm going to put that in for my R squared in the volume formula. And then you just clean everything up after that. All right, so that's how you do part A. Now with part B, again, we're going to take a look at that kind of volume equation in terms of, and be careful when we substitute that in. So 5/10, we get that because our radius was 5 when our height was 10. So if you reduce that down, you get 1/2 for RH. And again, we want to solve for R so that we can get rid of the R in our formula. So our formula, the way we had it written, was 4/3 pi, and then the 1/2 H is going to get slid in for the R squared. So be really careful when you slide in the 1/2 H for the R. Make sure that you square that. So when you clean all of that up, that's this middle piece right here where you get pi over 3 H cubed. All right, so that's our volume in terms of just one variable, just H. Then once you have it in terms of H, finding a derivative of that is pretty straightforward. It's just going to be dV dt equals pi H squared dH dt. Now the 3 variables, the only one we don't have is going to be dV dt. And it also, in the question, it says find the rate of change of the volume. So that's how you know dV dt is going to be the one that you have to solve for. In the original problem, they tell you that the water is decreasing at a constant rate, that the height's decreasing at a constant rate of -3/10 centimeters per hour. So that's why -3/10 goes in for dH dt. 5, they tell us in the question when H equals 5. So that's why that goes in for H. All right, then you do your arithmetic there and kind of clean that up. This bonus piece right here, but before yeah, it is. That was a typo on there. So this would be based on that, you know, what we have to work with for our formula, then we would go ahead and work with that piece right there. Now, with the part C, the bonus. So with the bonus, ooh, let's see, 10 more minutes. All right, cool. So we got 10 minutes and we'll wrap it up. So with the bonus, kind of the same thing. What's the constant of proportionality? And a couple of people did this a little bit differently and everything, but that's how you determine the constant of proportionality. So the pieces that we know are dh dt, because we know that's -3/10 because they tell us that. And then the h squared, you've got to get that represented in terms of r. And I think there were one or two people who did this slightly differently. That was also unique. So here's one way to find that constant of proportionality. And that. So while you're looking at that, let me pull up, let's see, I thought, Eric, let's see, calc or non-calc on quarter 2 test. Yeah, on the quarter 2 test, there'll be both parts. There'll be 10 questions that are calculator multiple choice and 1 free response. And then there'll be 10 multiple choice questions that are non-calculator and 1 free response as well. So both parts will have 10 questions and 1 free response on that. So Eric, I hope that answers your question about the format of the test, quarter 2 test. All right. So let's see, that's that. All right. Does anybody have anything else that they want to ask about in the next 4 minutes or less? Oh, test corrections. Yeah. So when you're doing your test corrections, and I think, let's see, this person did a really, really good one right here. So when you look at this, you know, Max, write out the original problem and then solve the problem underneath it, and then describe what it was you did wrong. Just, you know, write a note to yourself about what you did wrong. So if you're kind of looking format-wise, because you want to redo the problem correctly, so pay attention to the pieces that maybe you made mistakes on, whether it was a sign thing, an arithmetic thing, and just do the problem the right way. And then summarize what your mistake was. You know, was it arithmetic? Was it calculus? Was it, like on this problem, you know, I found the maximum of the derivative and not the maximum of the, or I found the maximum of the original function, not the derivative, because I misread it. A few people had some issues with just reading, you know, figuring out what the question was asking. All right, cool. Anybody else got anything? See, Eric, Aditi, Adiba, Elizabeth, you got anything? You're quiet over there. Anybody got anything else? It makes sense now. I think I got it. Elizabeth, what is the it? Oh, Ria, yes, thanks. Oh, thanks for coming back on. I'm so glad you're able to do that. And again, I'll put a recording of this up in Google Classroom and on my YouTube channel and stuff, and I'll share that with the teachers. But for those of you guys not in my class, just make sure to spread that word, you know, and those links and everything to everybody else so they can get some of that too. That was first quarter, wasn't it? EBT. Everything is fair game. Everything is fair game, whether it's EBT, MBT, yeah, those are all possibilities of everything. And you know there will be trig on there. Oh my gosh, wait, I have to go over this problem with you because it is driving me crazy to see you guys continually mess this one up. Let's see, which one was it? It was the one you guys just took. Was that? Yeah, you took it on the applications, I think. Was it this one? There's a e to a certain power. Maybe it's not that one. Miscellaneous unit, Calc AB. It was on this one. Where was it? Oh my gosh. Yes, question 7. Oh my God. This one is driving me and the other calculus teachers nuts because you guys keep making the same mistake. Like a lot of people are doing the product rule on this, and I'm like, oh my gosh, stop doing the product rule because it is just, it's crazy to do all that stuff. I mean, you can, and you'll get there, but what I want you to do is when you see this problem, you should be like, oh my gosh, thank you, Mr. Muscarella, because this is going to be one of the easiest problems ever. So when you do this problem, the very first thing that you want to do, you know, and I know we talk about this in class very often, is simplify early and often. So this part right here even a natural log of x, you got to recognize like even natural log cancels out and you're just left with x to the 4th power. That's it. And then be careful when you find the product, because don't forget 3x to the 5th right there, you're going to multiply that by x to the 4th, which gives you, because we know our algebra and exponent rules, we know that that's 3x to the 9th power. Taking the derivative of that all day, every day, you better get that problem right. All right, so that's one that has been driving us all crazy, because we see all this product rule stuff and people are mixing little things like that up, and it's just keep it simple. All right, simplify early and often, and that'll make your life a lot easier. And another thing too, like think about it from a grader's perspective. You want to keep your work neat and organized so that they spend very little time looking at your work. And I know most of you guys are really good about that. Cool. How extensive are derivatives on the exponents and logs going to be? I don't know, as extensive as they could be, you know, but think about it. It's only like an 85-minute test. That's all the time you have. So we're not going to put every single thing on there. But again, a lot of people made mistakes with formulas for the inverse trig ones or product rule formulas. A couple of people, there's one person who had the area formula for a circle wrong. You know, so those, you know, area formula for a circle, a rectangle, you won't get those. The only ones that they'll give you will be a cone and a sphere. Like you will always get those formulas given to you. Anything else, you've got to have that memorized. And that's so. How extensive? Everything's going to be derivative and chain rule and that kind of stuff. All right. Yes, you're welcome, Aditi. Anybody got anything else? Because we got like 30 more seconds here, give or take. All right, Rhea, do you have anything? You good? Eric, you're all set? And I think Elizabeth, when you said, I think it makes sense now. What was the it that you were struggling with? Oh, you worked from the slide. Okay, cool. So on the slide, was this one yours then? Was that one yours? Cool. Do we use f of x always? Be really careful because it's going to depend on what the function is, ADD. That's a really good question. Because sometimes your function might be f of x. If it's y equals, then just use y. Or if it's g of x, so you don't always use, always use f of x. Yeah, and Elizabeth, don't worry about reading it incorrectly. Like everybody who got that question wrong, that's why they got it wrong, because they're thinking, oh, I remember, yeah, I found the max of the original function, not the derivative. Yes, and do not say it. Oh yeah, absolutely, yeah. Never ever say it. Instead of saying it, you want to use f of x, g of x, whatever the function is that you're talking about. Because that's, you know, saying it, a grader won't know which thing that you're referring to. So that's why you always have to be really specific. You know, since f prime of x changes from positive to negative, there's a relative max. Since f double prime changes from positive to negative, the function is concave down. Since f prime of x is positive on a certain interval, you know, the function is increasing. So you're always going to want to refer, so you don't always refer to f of x or g of x. It's going to depend on what you're justifying in that. All right, cool. Anybody got anything else? Ooh. Oh, that's recording. We'll put that up later. All right, cool. Where's our chat? All right. Yeah, we're going to have another session tomorrow. No, tomorrow's all you guys, man. Tomorrow, I've got some projects to do around the house, and I need to take a break before we go crazy. But if you guys have anything that pops up, you're like, whoa, what about this? Just add it to the Google slide and shoot me a text on that via Remind, and I'll go ahead and get that out there to you. Is the homework applicable for +3 for this test? No, that was for your quest. you got 3 points, extra credit points added onto that. So the quarter test is just straight up quarter test grade. That's it. All right, cool. Thank you, Rhea. I appreciate you joining us.